Exercise 9G involves what we call compound interest investments with regular additions to the principal. So sometimes these questions are referred to as annuity investments. So you need to be now really careful when you're reading questions, because there's a difference between an annuity and an annuity investment. So you do need to be very careful with your reading of the wording, because you can easily confuse the two. So an annuity we've already talked about in exercise 9E, and then this one, as I said, sometimes referred to as an annuity investment. Okay, so also referred to as a compound interest investment with regular payments or regular additions to the principal. So what's happening in this sort of situation? Example 17 on page 29 of your booklet refers to a person, Noor, travelling overseas when she finishes VCE. She's already saved $1,200 and thinks that she can save an additional $50 each month. So basically what she's going to do is invest the $1,200 into the bank, meanwhile earning interest on that money, plus she's going to add an additional $50 a month to that investment. Okay, so it's like a traditional savings account. You've got some money in there and you're adding to that on a regular basis. Okay, so in this story, the interest rate is 3% per annum, and the interest rate compounds monthly, and we're going to use a recurrence relation to model this investment. So we know little r is 3% per annum. So to calculate the big R, we need to 1 plus that interest rate. So 1 plus 3%. Because it's monthly, we need to divide by 12. Okay, so the monthly compounding comes into it just like in every other question. So when we're writing our recurrence relation to model that investment situation, our V0 is going to be 1200. Our Vn plus 1 is equal to big R, which is 1.0025, times the Vn, times the previous year, the current year, and then we're going to add $50 to that per month. So it looks very similar to a reducing balance loan type situation with a payment happening, but very important to note that in this case we're adding the payment. We're not subtracting that payment. So that's the only difference in the way the recurrence relation looks in this situation compared to the others we've looked at before. So we can, if we are only asked for a few years worth of values, we might choose to use recurrence on the calculator to do that. Sometimes we might be asked to show the value of V1, V2, V3 using recursion, so we would have to show those calculations as well as the values there. If it's more than 3 or 4, even 5 values, we normally then would refer to a different method than the recursion method. Okay, so we can quite often be given amortization tables that summarize these investment situations. Some questions you might be asked to fill in a missing box like you have in the past. Sometimes you might be asked to show a calculation for a certain box. So you do need to be able to use your by hand skills here, as well as I'll show you the amortization software, how it works for this situation as well, because you can use this software as well. So it is important that you know how to do this by hand. So I've worked through a couple of the examples here, just month by month, to show you how this situation works, sort of step by step. So if you're having a look there, we're starting with a $1,200 deposit. So the Noor is putting in $1,200 into the bank account there. Then what happens is they make a payment of $50. Okay, so there's our $50 payment the first month. And then the bank calculates interest on the previous month's balance, so 0.25%. And that monthly interest rate there, I've showed you on the right hand side how I got that interest rate. So 3% per annum but because we're calculating monthly, we need to divide that 3% by 12. So it's effectively, we're working at 0.25% interest per month. Okay, so in that first payment there, 0.25% of $1,200 is $3. So what's happening is the bank's adding $3 interest, NOR's adding $50 payment, so that principal is increasing in that first month by $53. Okay, so by the time the first month is at the end of the month there, and it's all calculated and all totaled up, the $1,200 investment plus the $50 payment plus the $3 interest from the bank, we end up with a balance in the first month of $1,253. So then for the second month, you can see they make the second payment of $50. We calculate then, the bank calculates interest on the previous month's balance, so 0.25% of $1,253, and that equals to $3 and 1.325. So I haven't rounded off, so I'm just showing you on this little calculation here that I have not rounded off when I've used my calculator. If you were writing that value down as a nearest cent kind of calculation, it would be $3.13, but it's not exactly $3.13, it's $3.13 and a little bit more. So you do need to, when you're doing calculations by hand here, you do need to keep those unrounded figures in your calculator. Okay, so again, the principal increase comes from the $50 payment plus the interest from the bank. So it's an extra $53, effectively 13 cents, added on to the previous month's balance, and it continues on and on and on and on in that fashion. So I want you to have a play with your calculator there and make sure that you understand where those values are coming from. The page in your booklet there gives you 5 months worth to try to start with, and then when you flip over, you'll see there's another whole blank page of down to 12 months. So you have got space there to have a bit of a play around and see if you can get some values down there till 12 months is over. If you wanted to do that on your Amort Loan software, you can also do that. So if we were using the Amort Loan for this situation, when it asks us for the loan value, read that as investment value. So NOR puts in $1,200 into the bank. The interest rate per annum was 3%. The number of payments, if we would just want to show the same amount, I think it was 5 or 6, I can't remember if it was 6, maybe 6. The payment, because this is not a repayment, this is an additional payment, so we have to make some allowance here so that the software understands this isn't a loan, this is an investment. So this is the only, absolutely the only time when you're using this software you would use any negatives or positives here. And we need to tell the calculator that NOR is adding an extra $50. Okay, so that would be a negative payment in this case. Normally when we've ever used this before, we've been using it for loans, and we have never added extra to it. So when we even used it for an annuity, the payment was just a payment similar to a loan payment. So we don't have to worry too much there about anything other than this additional payment situation. So if someone's making just a repayment to a loan, or the bank is paying an annuity payment, that's just a normal situation. No positives or negatives on the Amort Loan. But when someone's making that additional payment, that's when this becomes an issue. The calculator can't understand what's happening unless we tell it. So we tell the calculator that NOR is making an extra payment by saying it's -50, and it is monthly. So when we do that there, you can see that the calculator works out for us the amortization table. So if you were doing a exam question where you had to just fill in one box, you might find it quite quick and easy to do just the software rather than doing the by hand calculation. So when you work through that part of the question there, you'll see on page 32 there's a little bit more rules and regulations when you're using a compound interest investment with regular additions or regular payments. This part down here again is the important part to remember, that the PV is negative because it's an investment. The payment is also negative because this person is making that extra payment, but the future value is positive. The money that's invested is this person's money. Okay, so the bank has got to give that back to them eventually, so that's a positive. So there is a quick example in page 33, and that is using the solver to determine a value of an investment. So just a quick one, a very straightforward one. Lars invests $500,000 at 5.5% per annum, compounding monthly. So he makes a regular deposit of $500 a month. So as soon as you see that regular deposit, you hopefully are aware that this is one of those extra payment sort of stories. What's the value of his investment after 5 years? So very straightforward use of the solver there. N is 5 times 12, 5 years times 12 monthly, 5.5% interest rate. The PV is negative because he's investing his money in the bank. The payment is also negative because he's putting that extra money in the bank. And the future value you can see there is positive. It's Lars's money. Okay, so after 5 years of investing at 5% per annum, 5.5% per annum, and additionally adding $500 a month to that account, the investment would be valued at $692,292.30. So quite straightforward calculations there. The exercise that goes with this one, once you've done some of those little examples in your booklet, is exercise 9G.